Okay, thanks for tuning in. Today we have Heidi Thornton discussing predicting self-reported illness for professional team sport athletes. So thanks for tuning in and thanks for joining us, Heidi.
Thanks, Rob. Thanks for having me on here.
It's great. I just want to firstly say a big thanks to Mike McGuigan for making the introduction. And then secondly, just to ask you to give us a little, maybe a little brief run through of the paper as a whole, and then we'll kind of get into the results and discussion.
Yeah, sure, no worries. So this research was actually part of my honours project. So I completed this, I think, 2 years ago now. First of all, I had another project which we had planned, but it didn't quite go ahead. So I actually had quite free reins of what I wanted to do at the club in terms of my honours project. And one particular interest for me was around illnesses. Just part of being at the club, I noticed there was lots and lots of illnesses occurring, and I wanted to figure out why that was, whether that was just the squad in particular, and how we could better prevent it. So I initially had another project set that was going to figure out this, but that didn't go ahead. So basically I implemented machine learning methods in an attempt to, predict or understand the contributing factors to illness, but using self-reported data, which we routinely get, just in an attempt to understand these contributing factors and compare that to previous research that's already out there.
Perfect. So you just want to take us through the results and what you found in this article?
Yeah, of course. So I'll just skip down to the results section. So as I mentioned earlier, we did use a different approach to previous studies. So previously they'd use traditional linear statistics, where we took a different approach. So as we had a whole lot of training load data and subjective wellbeing data, it was, hypothesized that it wouldn't take a typical linear relationship between, say, training load and illness incidence. So we adopted a different method. So I've actually used 3 separate machine learning predictive models. So as it was, a classification-based outcome measure, so whether they were reported sick or whether they were reported not ill, it kind of gave that 2-way outcome measure. So first of all, we implemented a decision tree model. So I won't go through the specifics behind all the parameters and all of that sort of stuff. I'll just go through the actual practical interpretation of it. So can you just see that here on the screen?
Yep, got it.
Cool. All right, so the top measure here, this is the first, one of the questions on our subjective measure that we collected. So it was just a general overall how you feel score. So all of these subjective measures were converted to a Z-score. So the first decision you can see here is that if your overall perceived well-being is below 2 standard deviations of the mean, then that's the first contributing factor to illness. So following that, if your well-being score, so this was an average of all of our measures. So if this was below 7.5, so this is not converted to a Z-score. So then you have a decision whether that's yes or no. So as you can see on the right-hand side here, if you're not below that, then it's more likely to be training load indicators that are contributing to illness, and on the left-hand side is more likely to be subjective perceived well-being. Okay, so the next method. So for each of these, we actually determined how likely they were to be able to predict illness. So one thing I want to stress about this paper is that in a practical sense, you can use this in a predictive, setting. So if you have all of this routine data for your club, then you can apply this for in the future. We're in a research setting. I admit that I shouldn't have used the word predicting because we are looking at this retrospectively. So we did identify factors that contribute to it. but we didn't report on any future cases of illnesses that did occur. But in our results section here, I do have the predictive capacity of this. So it basically sets the data up into separate data sets. It identifies the contributing factors, then it applies those results to the next set of data, and then that will give us an indication of how well it predicted future cases. So hopefully that makes some sense to those. Okay, so I'll go to our second one here. So this is what's called a random forest model. So each of these, we actually chose the 3 different methods just based on their different pros and cons that they have. So the decision tree model is very good for interpreting the data. So it's really quite easy for strength and conditioning coaches because it says it there what measures there are that contribute, and then it's just easy to understand, where the random forest and the boosting aren't so much, but in terms of their predictive capacity, they are actually a little bit better. So that's just a quick understanding as to why we included the 3 methods. Okay, so basically here there's 2 separate measures which the random forest give us. So I won't go in depth of what they mean, but we've got the mean decrease accuracy and the mean decrease Gini. So I've actually had to make these figures just because the ones through R aren't that publishable. They're not that great. So first of all, we can see that strain is the greatest contributor to illness incidence for this squad, followed by the weekly training load and monotony. So basically, the random forest algorithm just takes a large number of decision trees, and it identifies which factors were recognised within the decision trees, and then it just gives them a weighting score. So that's where the accuracy and the Gini comes from. And that's, so basically strain was identified as the greatest contributor throughout the many decision trees that were developed. So below this, we've got the boosting model. So the boosting model, again, is, I guess, an extension of the random forest model. So as you can see here, again, strain was identified as the greatest contributor, followed by a reduction in the wellness average, and then again, monotony. So the difference with this model and the random forest is that it actually associates a weighting score with it, depending on how well it actually predicted the illness case. So if it incorrectly identifies a measure, it'll bring it back, where if it correctly predicts it, it'll put that weighting score up. So as you can see here, strain is quite well above the others, but we actually have a mixture of training load and subjective measures that were able to predict illness rates. So that's a bit of a basic understanding of what we found. But overall within the study, there was actually a large number of illness cases. So by memory, there was 36 in total. And during competition, it was actually quite, relative to the amount of time there was, it was actually quite higher than what pre-season was. So to us, that indicated that perhaps it's a combination of training load, but whether or not it's a lack of sleep or the travel that they undergo during competition. So it's more of an interaction between a lot of the demands of their unique environment that contribute to illness. So the data we collected was across 29 weeks of the Australian Rugby League season. So we collected data off the entire squad. So that was 32 athletes. So that was from the top tier squad from the NRL and the full-time squad from the New South Wales Cup. So they all completed the same training. For the training load measures, what we did was just use the RPE, and then we collected self-reported information. So I'll just go down to the actual screening form that we use below. So we collected this once a week on the first training day of the week. So all the athlete had to do was tick whether they were sick at that point in time, and then tick the boxes for whatever symptoms they had. And if they did have any symptoms outside of that, they just wrote it down. So we did need to be careful with it, the fact that they weren't just, writing that they had a runny nose and they weren't actually were infected. So they did actually have to be screened by our doctor to determine this further. So the second part of the questionnaire was the general wellbeing section. So there was 3 questions which they had to, 4 questions, responding to a 1 to 10 Likert scale. So how closely did they follow their dietary guidelines? How restful was their sleep? General, how do you feel? And how sore are you? So we actually took an average of these 3, but we also had them in individually as well. So we could have an indication of, was it a reduction in their sleep was more likely to contribute to their illness. So then with the data, what we did was actually included their measures from the week before to predict illness in the following week. So we could actually understand leading up to their illness rather than at that particular point in time. And
cool.
Yeah, I'm not sure.
Cool. No, that's great. That's great.
Cool.
Where can people get hold of the paper, Heidi?
So we actually submitted this in International Journal of Sports Physiology and Performance. So even though it is quite a I guess you could say statistics heavy paper, we did try to take the most practical approach as we could to sort of show strength and conditioning coaches that, there is, and sports scientists, that you can use these techniques in a practical sense, and it can become part of your routine monitoring practices if you know how to do them, and can give you a better understanding of factors that contribute to either illness or injury in a more robust way than what traditional statistics could.
No, that's great. So where can people keep up to date with what you've got going on? So you're on Twitter?
Yeah, I'm on Twitter. I think my handle's HeidiT09. But my most recent research is on ResearchGate. So you can just search my name for that. And LinkedIn, so just my name again, Heidi Thornton.
Cool. We are coming up to the magic 15 minutes, so timed it absolutely perfectly.
Excellent,
so thanks a lot for your insight and for going through the paper with us. Sorry about the mix-up for the timings.
No, that's okay. No worries at all. Thanks for having me on.
Thanks a lot.